So when we look at the bird, of course, we know that this is a living dinosaur, meaning that its most recent ancestor was a dinosaur. And so we see a lot of vertebrate traits. We can see, for example, on the foot, the scales, like we would see on a reptile. We can see some of the ancestral traits like the nictitating membrane. This nictitating membrane serves the same function as we see in sharks and frogs and cats, and that is it protects the eyelid, serves as kind of a goggle, which is especially important during flight. Of course, when we look at the when we look at the pigeon, we see the pigeon has obviously a beak, and if we open up the beak, which gets a little bit tricky because they have a little bit of reduced mobility because of the preservative. When we open up the beak, can you see inside the beak? You can see there's no teeth. There is a tongue, obviously, here, but there's no teeth that we're looking at. When you look at the beak, you can also see the cere of the nostril. That is this portion in between here, this type of material there, that tissue. Of course, one of the most noteworthy features of a bird is the feathers. The feathers are made of keratin, and they are adapted scales. And we can see different kinds of feathers. So we have the flight feathers on the wing as well as on the tail. They're the really long ones. And if you feel the flight feathers, you probably can't feel it, but if you see, there is, this spine or ridge here, and that is the leading end that would cut the air. Also, if we splay the feathers, you can't see it quite as easily unless, Caitlin, can you zoom in at all? Not sure that you'll be able to see it, but you can see it in the handout that there's a barb wire and a barbing going on where it can interlatch. And that is very helpful to help keep the bird, help it thermoregulate, especially when it's wet. And a bird spends a lot of its time rehooking its barbs. And even if I make all the feathers kind of janky there, it doesn't take much for them to reorientate and re-smooth out their feathers because of that preening. Now, when they preen, the birds are going to take advantage. I'm on the dorsal. This bird is a little bit twisted, but I'm on the dorsal side, and if I look, and it takes a little bit of digging, I pick up some, these are contour feathers, and then these ones underneath here, these are downy feathers. The contour feathers are the ones that would like give them their coloration and things. But if I pick up the contour feathers and the downy feathers, we'll see right there that triangular structure. Right here is the preening gland. And so they're going to pick up oil from there, and they're going to rub it around their feathers to help them preen, and to stay warm. I showed you already, but let's take another look. A real good look at the shape of the foot. You can tell by the handout, kind of, again, because of the way it was preserved and then packaged, they're a little bit hard to see the shape, but you can tell given the shape, this one normally would orientate itself back with 3 forward. You can tell given the shape what it likely, what its feet are adapted for. Okay. Also, let's look at the beak one more time. Notice the shape of the beak. Take a look at what, given the shape, what type of adaptation do you think the bird has for eating? Now, once we get into it, depending on how recently this one ate, we might be able to see some of its food. Let's take a look when we peel back the eye. The nictitating membrane, you can see that it has a lot of the same features. Let me actually cut off the nictitating membrane a bit. How many minutes are we on?
5.
Okay. Cut off the eye. Caitlin, if you get in there real close, you can see the iris of the eye. Maybe.
So blurry.
Maybe try zooming out a little bit, or backing off a little bit. see the different color, just like ours. If we cut the eye open, you can see it's not hard, just like ours is not hard. Whereas some of the other organisms we looked at did have it, and you can see the vitreous humor come out when I cut it open. Okay, alrighty. So we've removed some of the feathers here, and when we remove the feathers, you can see a couple of things. First off, you can see the insertion points of the feathers, the prickling. You're probably familiar with that anytime you've eaten chicken or turkey or something like that. And then you can also see this ridge here. It actually goes further up, but this one, again, he or she was kind of squished during preservation. You notice it's got a little point down here, so that's the end of the sternum. This ridge is the sternum, and the projection goes out here. Let me get this corner. And the projection goes out really, really far, because this is the attachment point for all of these really, really thick muscles. So in a few minutes, I'll cut into that and you'll be able to see where those muscles are. And that's because as the bird flaps, there's a tendon along here, the patagium, that connects here. And all of these muscles are controlled, all of the flight is controlled by the pectoralis muscle. So there's so many muscles here. That's why bird meat, when you typically eat chicken breast or turkey breast or whatnot, because you're cutting through this huge wealth of muscles. Okay. So I'm peeling off the skin, and you can see this tissue here. This is connective tissue that holds the skin. So to get the skin off, we're going to cut that with a scalpel. Okay, I've pulled the skin off of the leg and lower abdominal area, and you can see the leg joint, the tibia, is the femur is here, and the tibia is where I'm holding along the fibula. And the iliotibial muscle, ilio refers to the hip area, tibia refers to the lower leg, which is where I'm holding, and this big muscle here, which if you have wings, or not wings, chicken legs, that's mostly in the meat that you're eating, and that is that muscle that we see moving there.